Okay, today's section is 7.4 special right triangles. Now you're going to notice we skip 7.2 and 7.3, but those are unrelated. So theorem 7.8. This is basically our rules for special right triangles. The first one is a 45, 45, 90. Now the 45, 45, 90 refers to the angles of the triangle. So if you have a triangle that has a 45 degree, 45 degree, and a 90 degree angle on it, then you know this rule is true. The hypotenuse is the square root of 2 times as long as each leg. So if I have a leg here that's x and a leg here that's x, then the hypotenuse is x times the square root of 2. Okay? When we put this into action, it becomes a little more apparent. So if I find the length of the hypotenuse, here it gives me a 90 and a 45. No, there's 180 degrees in a triangle, so if it's a 90 and a 45, that automatically makes this a 45. Okay, so now we have a 45, 45, 90. This leg is 8, which means this leg's also 8. And since those are both 8, this is the hypotenuse, because it's opposite the 90, and it is 8 times the square root of 2. So it told me to find the length of the hypotenuse. That's all you have to do. This one B, we have a leg that's 3 root 2 and 3 root 2. This makes this isosceles, which means these angles have to be equal, which means they have to be both 45s. This is 45, 45, 90. Find the length of the hypotenuse. That would be 3 root 2 times root 2. Now, anytime you multiply roots, you just get rid, if they have the same base. So if it's both 2, then you get rid of the root, and it's just 3 times 2, or 6. Find the lengths of the legs. We start with a hypotenuse that's 5 root 2. So each leg has to be just 5. Because they're both x, which means they're the same. Makes it an isosceles triangle. So this is really just learning the rule and all the different ways that it applies. Pretty simple though, not bad. I think we're going to do a couple more examples on this. This thing is driving me crazy today. Okay, find the value of the variable. Here we have an x and an x for the legs, which means it's isosceles, and your hypotenuse is 2 root 2. Remember, hypotenuse is the length of the leg times root 2. So if we're going from the hypotenuse to the leg, you just get rid of the root 2. Those are both 2. Here we have root 2 and root 2. So it's root 2 times root 2. Those cancel out because the bases are the same, the number inside is the same, and so it just becomes 2. Look at number 3. They're all 8s, so when we put a diagonal in, the diagonal is 8 times the square root of 2. Okay? All you people ever who wonder, when am I ever going to use this? This is used a lot whenever you're looking at squaring things off, like in architecture or carpentry or working in a mill. You need to make sure that your sides are square because it'll look like it's a perfect rectangle or a perfect square. So what they'll do is they'll have you figure out what the diagonal is. Once you figure out what that diagonal is, it shows you that it's got to be square. Like say this side happened to be a little longer on those sides. If I measure my diagonal then, and so on a regular tape measure it might come up that this is just 8, you know, but it could be like fractions of an inch off. But whenever I measure this, it comes up 8. Doesn't necessarily mean that it's dead on. So I guess it's not really a great example of it. A better example would be like this. And so it wouldn't be tilted nearly as much, but if I can measure all my sides, they would all be 8. And so when I needed to find my diagonal, I would need that to be 8 times the square root of 2. And it would come up not being that much. It would come up bigger than that, which would tell me that I was off. So anyways, that's how it can be used in real life situations like that. Alright, on to the next special right triangle. That brings us to theorem 7.9, which is a 30, 60, 90 triangle. So in a 30, 60, 90, the hypotenuse is twice as long as the short leg, and the longer leg is square root of 3 times as long as the short leg. So we have the short leg, which is the one that's opposite of 30. Then to find the hypotenuse, you multiply it by 2. To find the other leg, you multiply it by the square root of 3. This one we have the short leg being square root of 3. If I need to find the other two sides, I multiply this one by the square root of 3. So it's root 3. And the hypotenuse would be 2 root 3, because I just multiply the short side by 2. This simplifies to 3. The roots cancel. Pretty easy. Find the length of the hypotenuse. Again, we're looking at some 45s here, just getting extra work in. So this is 6. Remember 45, 45, 90 makes that 6 root 2. 4 root 2 and 4 root 2 say that this is a 45, 45, 90. So those are 45s. Then this would be 4 root 2 times root 2. Remember your roots cancel, you get 4 times 2, which is 8. I might want to pause this video. Kind of flying through these problems the more I think about it. Alright, windshield wipers. Car's turned off, all the windshield wipers are moving. The 24-inch wipers stop, making a 60-degree angle with the bottom of the windshield. How far from the bottom of the windshield are the ends of the wipers? Okay. So here I got my hypotenuse. It's 24 inches. I need to find this vertical. So the first thing I have to do is find what my short side is down here. Now remember, in a 30, 60, 90, your hypotenuse is 2 times the length of the short side. So just take this and divide it by 2 to get 12. Then this side is 12 times, or the short side times the square root of 3. So that would just be 12 root 3. Now in the real world, 12 root 3 isn't going to tell me very much. Like if I walk up to someone and say, oh, don't worry, it's only 12 root 3 inches from the bottom. It's not going to mean a whole lot to them. So calculating it out, they give me about 20.8 inches from the bottom of the windshield. Okay, number 3 down here. I don't know why I numbered number 3. Actually, I do know why I pulled the example from somewhere else. 2 root 3. Let's just find everything. This is your short side. It's 2 root 3. So I multiply this by root 3. Roots cancel. We're left with 2 times 3, which is 6. To find my hypotenuse, multiply the short side by 2. So it gives you 2 times 2 root 3. It just gives you 4 root 3. And that's it. This one here, since this is 12 and 12, tells you that this was original. Well, it was 12, 12, and 12 because this is 6 and 6 on the bottom. So it tells you it was originally a 45, 45, 90. It was not a 45, 45, 90. It was 60 degrees all around because your angles were 60 degrees. It was an equilateral triangle. So those were all 60 degrees. Now we cut this top angle in half. So it's 30 degrees. Now we have a 30, 60, 90. Short side is 6. So to find your height, you just multiply that by the square root of 3. So your height would be 6 root 3. That's it. Your worksheet will reflect a lot of problems very similar to this. I will post a video on how to do the worksheet. Seniors, I don't know how it's looking for final. You are going to have a final exam, so start pulling your materials together for the second half of this year. I'm only going to do it on the second semester. So that would be chapter 4, part of chapter 3, chapter 4, and then this stuff. Alright? So I will have seniors continue to work through this while you guys are taking Keystone, while the 10th and 11th graders are taking Keystones, if they have to take them. If not, then they'll just be working with it with the seniors. Then we will progress from there. But seniors, you only got another week left. Alright guys.